that has a rate of change is a differential equation. So we're going to talk about a rock being thrown upward here. It says a rock is thrown upward with an initial velocity of 132 feet per second from the top of a 48-foot tall building. We know that A equals negative 32 feet per second squared. You might have seen that before, or most of you probably have. In what class? Where have you seen negative 32 feet? Physics. What is that? That is the acceleration due to gravity. Exactly. So you know that the acceleration at any time due to gravity, A of t, is negative 32 feet per second. You've seen that before. One key thing to note here, please be careful not to use any straight physics formulas. We need to do this with calculus. There are ways where you can jump over steps. Here's effectively where some of the formulas you've learned in physics come from. Okay, if that's acceleration, how do you get velocity from acceleration? What do you do to acceleration to get velocity? You integrate, because the rate of change of velocity is acceleration, so the integral of acceleration is velocity. So you know that the integral of acceleration dt is equal to the velocity, right? Plus c. Well, in this case, we have an acceleration. Oh, it's negative 32 dt. What is the integral of that in terms of t? What's the integral of negative 32? Yeah? Not x. 32t plus c. So we now know that v of t is negative 32t plus what? C. So that is almost done. What do we need to solve for? The c value. We need to know what that c value is. There's a piece of information in the initial line. There's a piece of information in the initial line that will tell us what that c value is. The initial velocity. So it tells you an initial velocity. So initial means what number? When it says initial, that means the velocity at time what? So this tells you that v of 0 is 132. So when you plug in 0 for t in the velocity function, you should get out 132. So since v of 0 is 132, what does that mean we now have? It means we can plug in 0. Why do we like plugging in 0 into things? Well, not always, but in this case it does. But you plug in 0 because when you plug in 0 times anything is, so you have this. So what is c going to equal? So now do we have the velocity function? Yeah, negative 32t plus what? 132. Hey, that's nice. So we now have the velocity function. We can find the velocity of that rock at any given time. Excellent. Okay. Now it says express the height of the rock as a function of time. The height of the rock is a function of time. So that means we need the position function. The position function. What's the relationship between velocity and position? Yes, Sarah.
Velocity is the derivative of position.
So the integral of velocity is?
Position.
Yes, s of t plus c, right? So we're doing the integral of negative 32t plus 132 dt. Can someone tell me what that is? What is that integral? Yeah, Sarah.
Negative 16t squared
Yep.
plus 132
T plus.
c.
So now we just need to solve again for what? C value. But what do we know from up here? We know that the top of the ladder is where it was thrown from. So that means the position at 0 is what? 48. The position at 0 is 48. So since we know the position at 0 is 48, where do we plug in 0? We plug it in for t. So or t right there. Negative 16, 0 squared plus 132 times 0 plus c equals what? 48. So what does c equal?
48.
So now do we have the position function? Yeah, we have the full position function. S of t is equal to negative 16t squared plus 132t plus 48. And now, it's been a while since I've been in a physics class, but have you guys seen negative 16t squared before? A whole lot? Yeah. And usually this right here, what does that correlate to? That is your initial velocity, right? And what is this? Your initial position. So you've probably done something like this before, but not with the integration, probably. Okay, so for part C, don't do, this is when what? When v of t is equal to 0. Okay, what about D? How long does it take to hit the ground? What is 0 when it hits the ground? The height. So you know that S, this is when S of 0 is equal to 0. So find a piece of the board with somebody else. S of t. So find a piece of the board. I'll keep those equations up there for you. So you have your velocity right there, and you have your position function right there. Use both of those to solve C and D. So you have to plug 4.125 into S, and you end up at 320 1/4. So that's the highest. That's pretty high. If that's a person throwing it, that's really high. So S of t equals 0. When you do that out, do you end up having to use the quadratic equation? Yes, you do, and you end up with two answers: 8.599, I think, and what else? Negative 0. What?
348.
348. So the reason there's a negative one is if you look at this situation, this person is throwing this rock from a ledge that's 48 feet high. It goes up and down, right? Like that. So you can kind of think of it as there's this negative time where it, quote, would have been at the ground, maybe, if you followed that same path in reverse. So this is at time 8.599. Okay, it says how long does it take? Well, it takes 8.599 seconds. Look at part E. What is the velocity of the ball just before it hits the ground? How do you find that out? You just found out the number you need. You plug that number into the velocity function, right? And you get, it's like, can someone do that now? It's the velocity function's right there. It's negative 32t plus, oh, I highlighted the wrong one here, sorry. This one right here, negative 32t plus 132. So negative 32 times 8.599 plus 132. Can someone do that for me? It's going to be negative
143.160.
Yeah. So why is it negative? Why is it negative?
Because it's going down.
It's going down, yeah. It's going down. And 143 feet per second, does anybody know how fast that is? That's pretty fast. I think 88 feet per second is 60 miles an hour. So it's like almost 100 miles an hour. 100 miles an hour? That's pretty fast. Now the question is, would the ball ever get that fast? Why not? You end up with, what's the acceleration, Liv? The acceleration is just negative 20 feet per second, right?
Yeah.
So this would mean that gravity is a little bit less powerful, right? The gravity is less strong, right?
Yeah.
So you integrate this, and what do you get? You get v of t is equal to negative 20t plus c. But you know the initial velocity is what? What's the initial velocity? Is 100, right? Oh, that's not the initial velocity. What's the initial velocity? 15. So this 15 actually ends up going right there. So what do you end up with? V of t is equal to negative 20t plus 15. And then you do the position function, which is just going to be negative 10t squared plus 15t plus c. And where's that number going to come from? Right there. Because you plug in 0. Oh, it's nice. You get s of t. This is nice because these are all initial conditions. Initial means you're plugging in 0. Is plugging in 0 about as good as it gets?
Yeah.
Yes. Now, do they have to give you an initial condition? No. They could have said that the velocity at time 2 is a certain number. It just means plugging it in is a little different. That's it. 0 is nice because everything cancels on these. 0 is nice because everything cancels.